Hello, everyone. I'm delighted to be here talking to you about Signifyd's approach to building machine learning models. I am Swami Vaithi. I have the privilege of leading an amazingly talented group of data scientists here at Signifyd. I've been here with Signifyd for almost 2.5 years now. And prior to this, I was with Google. I was leading their payments data science team. And prior to that, I was with PayPal. All right, let's jump into the presentation. So for today, I want to cover Signifyd's machine learning philosophy. I'll talk in detail about the feature engineering that we do. I'll talk about the algorithms that we use. And finally, I'll talk about how we deploy models and how we monitor their performances. So Signifyd, a lot of the products that we have today in the market, the core machine learning forms the core for all of these products. However, we take a very holistic approach to how we think of machine learning here in Signifyd, and that changes how we build models. First and foremost, we have designed our products to be simple for our merchants to use. We want the minimum possible lift from our merchants to be able to take advantage of Signifyd's products. That's number one. Number two, Signifyd has been in the fraud fighting business for almost a decade now. And through this decade, we've accumulated a lot of domain knowledge and we've codified them in our features. And we'll talk a lot about how we build our features. And the third thing is, in the same decade or so, we have had the opportunity to serve a lot of merchants across multiple verticals. So today, any new merchant who joins Signifyd's network benefits from all the data and the network strength that we've collected over the years. And vice versa, whenever we add a new merchant into our network, the network also becomes stronger. So when we build models, we want to make sure that we leverage this network strength, both depth and the breadth of our network, to build excellent models. The fourth one is we separate our business optimization layer. So there are merchants who have a higher risk tolerance than others, even within the same merchant. Sometimes, depending on the region, depending on the time, depending on the product, the merchant might have a different risk appetite for different reasons. Because we separate the business optimization layer, we are able to gracefully handle all these custom requirements. And last but not least, we have a robust machine learning infrastructure that we continue to invest a lot into. So let me briefly touch upon Signifyd's commerce protection platform. Signifyd's got one of the most unparalleled set of products that we offer in this fraud prevention market. Signifyd's techniques together bring online experience, the buyer's online experience, and and seller's quality control. We have multiple products in offering that does this. And Signifyd's commerce network, as I mentioned earlier, is one of the strongest one. Even if the merchant has never seen a new customer, there is 98% chance that Signifyd has seen this user before. We have a great depth of coverage in several of our attributes. We cover both transactional and behavioral data from thousands of our merchants. And we also use third-party data to augment our data sources. I'll talk briefly about feature engineering. So Signifyd's approach to feature engineering is that the models will be as predictive as the features are expressive. So we spend a lot of time encoding as much behavior into the features themselves rather than throwing data at the models. And we also have a separate team of subject matter experts who we consult with when we design these features. When there's a new fraud attack, when there is something new happening in the market, then the subject matter experts actually help us design these features. And over the last decade or so, we've been very meticulous about collecting these fraud MOs and the features that we create. And we've built an enormous library of features. Um, and lastly, we are source agnostic. We will use whether it is internal data or third-party data as long as it improves the model performance. So I talk about features. I want to give a good, quick example of what we mean by a feature. So in this case, I'm talking about purchase IP maximind proxy score. Here, we are getting the IP information from the merchant when the buyer was purchasing an item. We take that IP, we farm it out to a third-party vendor, in this case, it's Maxmind, to get their proxy score. And what we are looking at here is a univariate analysis. On the x-axis, you have proxy score. On the y-axis, you have the fraction of GMV that's either good or no chargebacks, or it resulted in a chargeback. What we are looking for are features that separate bad actors from the good actors. An excellent feature would do it without any other feature. In this case, it's pretty obvious when the proxy scores are very high, then the chargeback rates are going to be very high. There are also other features where it only makes sense in combination. But the ultimate goal for us is to be able to separate good from bad. That's what we are trying to achieve when we are engineering a feature. So there are, like I mentioned earlier, we have a library of thousands of features, but we categorize them across 4 different dimensions. Identity features, behavioral features, history features, and device features. And I'll go into them at depth in the subsequent slides. So let's take identity features. So Signifyd has a fairly sophisticated identity graph engine behind the scenes, wherein we take the data that the merchant sends us. We have data that Signifyd already has. And then on top of it, we also go to third-party vendors like Threat Metrics and Tower Data and Icada to augment this data. And all of this happens seamlessly in the background. So when it comes time to build a feature, in this case, we are talking about a user, Emma Picard, who's trying to make a transaction on one of our merchant accounts. And we get merchant data like email address, epicard@hotmail, and the cardholder name, Emma Picard. So we've built an identity graph for Emma in our database. And now we are looking for the reputation of these online elements. You know, how long has it been since Signifyd first saw this email? How long has it been since the email was ever created? And also, we are looking for consistencies and inconsistencies among the different attributes that we are seeing. In this case, the email address is ePicard and the name is Emma Picard. And we are saying, oh, there is a pretty good match between the email name and the cardholder name. And similarly, we've gone out through a third-party data provider. We are able to get their social name. Again, it matches exactly with the cardholder name. And we also see that the card bank is from France, and the billing address is also in France. So there are a lot of consistencies and inconsistencies that we are able to observe with the identity graph that we built for Emma. The second class of features are the device features, in which case, in this case, we have the IP address, which is the address of the device that is making the purchase. So we have information like, okay, this IP was from France. The billing distance, the billing address is about a mile and a quarter from the IP location, and it's a residential IP. So these are augmented data elements that we are able to acquire from Maxmind directly. And the second part of it is that we also collect device level information. And this is through a third party called Threat Metrics. And we are now able to get what type of a browser they're using. Are there any Is this a virtual machine that they're using? Is it a remote desktop that they're using? Have we seen this device before? And et cetera, et cetera. There's a whole range of features that get calculated again seamlessly behind the scenes. And we are able to use all of that data to augment the initial data set that the merchant provided us. The third class of features is we call behavior features. Um, Imagine I'm buying some gift for my surprise gift for my wife, and I my natural way of interacting with the website would be I go into the homepage, I'm going to go look at the product that I'm trying to buy. Let's say it's a ring, and I'll add the cart. But I'm also going to be making sure that the ring is to the taste of my, what my wife likes to wear. Is it something that she would, enjoy or appreciate? And I'm looking at all the different attributes, different products that are offered, and then I add that item to a cart. Then I enter my payment information. So there are quite a few information that I've already collected. Signifyd's already collected on this page. How did the user enter the page? How long did this user spend on the page before adding the item to a cart? And we also collect the typing pattern. Is it something that matches what we've observed in the past? Now, let's say it's a surprise gift. Now I have this question in my mind: is the ring size correct? What happens if she does not like it? I need to go return it. What is the return policy like? So I'd like to be able to tell if this user has looked at the return policy. So we are able to collect all this information. On top of that, we also can collect other information that we can use to establish consistency, like the time this item was purchased. Um, is there even slight variations in what we are seeing, what threat metrics is reporting, what the merchant is reporting? So all of these things become part of our features that are available to build into our models. And then the last one is the history features. This is the classic set of features that everyone's sort of aware of. In this case also, we separate it into two classes. One we call in merchant history. For this merchant, does this order sound like an anomalous purchase? Is this person buying hundreds of thousands of iPads, for instance? Or is there like a velocity attack? Is this person making a lot of transactions? At a user level, is this an anomaly? At the merchant level, is that an anomaly? And or it could be an anomaly at the level of the vertical. And you can see some examples here by confirmation phone, by IP, by delivery address. So that's one class of features wherein we kind of capture the vertical information, the merchant information, and the user level information. Then the second level is where we use the breadth and depth of our network. And here we are seeing that, hey, is mperez@hotmail.com, has that been ever seen? Maybe it is new to this merchant specifically, but more than likely, Signifyd has seen this person. What's the history like? Is this person someone who's filed chargebacks before? Does this person frequently return items? All this data is captured in our history. Also, we also get to see all the good users across our merchant base. And now we can say that, oh, this is a trusted user. We've seen this person for a very long time with zero negative events. So it is very efficient for us to find trusted users as well. So those capture the four features that we have. So I'll go briefly into the algorithms that we're using. So we talked about the data elements. We talked about how features are created. And now we are going to talk about how we build our models. Um, Signifyd builds a lot of different types of models. The model that I'm describing is one of the core models that we use. This model actually ends up producing decisions that we ends up producing the decisions, but there are also other models whose output would be a feature. So when I'm talking about this specific model, we are talking about this model is training. And there are two components to it. One is the algorithm, and the other is how, among the tens of thousands of features that we have, how do we select the right features for this set of training data? The outcome of a transaction is predicted by, in this model, by the historical patterns that we've observed. Now, like I mentioned earlier, better features, we try to make sure that the models take advantage of all the expressiveness that we've built into the features. And all the patterns are built on top of the features that patterns that we've already established through the features. We use a model algorithm called XGBoost, and then we also have several different ways of doing feature selection. So very briefly, XGBoost is extreme gradient boosting, and the evolution of it is that earlier, there are simple rule-based systems that just uses decision trees. Um, the next one was random forest, which is like a lot of trees and you aggregate the decisions. And the latest is boosted trees. And for tabular data, XGBoost is considered to be best in class. Um, and in this case, every subsequent tree that we build tries to fix or reduce errors that were uh, that were the result of the previous sets of trees. So compared to random forest, the performance is a lot better, but it does require some careful tuning, and there is a lot more pre-processing that we need to do. We also use something called regularization to make sure that the features that we select are appropriate and would give us the best results in the live environment. And I want to talk about model creation life cycle. So here, what we are trying to do is that we have this process of an offline model creation, and then there is an online evaluation as well. Offline, we create hundreds, sometimes thousands of models in trying to uh, pick out the best model for the problem that we are addressing. We typically use about 24 months of data, and we rapidly introduce and test new features. We eliminate as many bad models as possible, and then we go into the offline evaluation, which would take data set that the model has not seen. It's out of time validation that we do, and we pick the model that maximizes the area under the curve and every other metric that we have. Um, so that's sort of a quality gate for our offline evaluation. When it comes to online evaluation, we run these models in parallel. We call it the champion challenger setup, where the champion is the current model and the challenger needs to perform statistically significantly better than the champion for us to make the challenger the new champion. And for this, we conduct several rigorous tests, and sometimes it lasts up to 6 weeks. And once we decide that the challenger model is the better one, we will graduate the challenger model to champion, and on it goes. At any given point in time, there are hundreds of experiments that are happening behind the scenes. And we have quality gates like, you know, obviously the chargeback rate should be lower. We want to make sure that our subject matter experts are comfortable with the declines that we are seeing. And we are also making sure that there is no degradation in the features that are used in these models. And I want to also talk about the continuous learning aspect of our models. We have four different parts that supply um, this feedback into our models. One is, of course, our fraud analysts who are looking at our decisions, our models' decisions. They're reviewing them, making sure that the decisions make sense. Are there any outliers? Are there good transactions that we are declining, or vice versa? And they are detecting fraud trends that help us develop features and make appropriate changes to our models. Then, of course, we also collect a lot of chargeback from our merchants. Um, and this chargeback data is submitted for reimbursements. And we use this as false negatives. And we are looking at changing fraud patterns and making sure that we catch all of them. Thirdly, we are also a fairly open system where the merchants can actually review our decisions and provide feedback. They can thumbs up a transaction that we might have declined, or thumb down a transaction that we might have approved. And that's a feedback that we also get in again continuously. And last but not least, we also have pre-auth models today, wherein we get the bank auth data, which is again another quick signal that we get to course correct if need be. And usually a bank auth failure is one of the indicators of fraud in our world. So that concludes the presentation. I'd want to make sure that if you have any questions, I'd be more than happy to answer them. Um, Thank you.